Hello friends, welcome to full course on Signals and Systems by Darshanam. In this lecture 1, I am going to discuss some of the basic topics of signals and systems. The topics include definition of signal, continuous time signal, discrete time signal, and step function. Let's start with the definition of signal. Signal is a physical quantity that varies with time, space, or any other independent variable or variables. So, signal is any function which is having some information and that will vary with time, space, or any other independent variable or variables. If signal varies with one independent variable, it is called as one-dimensional signal, and if signal varies with two independent variables, it is called as multi-dimensional signal. In all technical exams, we have to deal only with one-dimensional signal, but we must know the difference between one-dimensional signal and multi-dimensional signal, so it will be useful for our interviews. Now let's see the examples of one-dimensional signal. Voltage signal and current signal are examples of one-dimensional signal. Let's see that is voltage signal V of t can be written as Vm cos omega t. Here the voltage is changing with respect to time, where time is an independent variable since we cannot control time. So, voltage signal is a one-dimensional signal which is varying with t. The same is the case of current signal I of t. That is I of t equal to Im cos omega t. Here also the current is changing with respect to time. Then we can see the example of two-dimensional signal. That is, image is an example of two-dimensional signal. We know that image is nothing but a collection of pixels. That is, we can define image by using its characters such as color, intensity, brightness, etc. Consider the brightness, that is the character brightness. If we consider, it will change from one pixel to another throughout the image. So, here there are two independent variables in x-axis and y-axis. But the two independent variables are same and it is space. So, image is a two-dimensional signal which is varying with space in x-axis and y-axis. So the definition of signal is any physical quantity that is having some information and it will vary with time, space, or any other independent variable or variables. Now we can see there are two types of signal, that is continuous time signal and discrete time signal. From the figure, it is clear that the continuous time signal is defined for all values of time, whereas in the discrete time signal, the signal is defined for only discrete time intervals. Here, the time is specified as n, where n is called as index or time index. The n can only have integer values. We can see from the graph that it is -1, 0, 1, 2, 3, etc. The signal is defined only at these integer time intervals. In between -1 and 0, no signal is defined, and between 0 and 1, no signal is defined, and so on. So, continuous time signal is defined for all values of time, whereas discrete time signal is defined only at discrete intervals of time. In the case of discrete time signal, we can call the signal as sequence or signals. In case of continuous time signal, we can call it as signal. Why discrete time signals are called as sequence? We can see that the discrete time signals can be represented by a sequence of numbers. Here x of n is equal to 1, 1, 0.5 minus 0.5, 1, 2, 1. These numbers are magnitudes of signal at n equal to -1, 0, 1, 2, 3, etc. Here we have to mark the origin of signal, that is for which is the magnitude of signal n equal to 0 at n equal to 0. It is defined generally by using an arrow. That is here the second one is marked by arrow. That is 1 is the signal magnitude at n equal to 0. So since we can define the discrete time signals as a sequence of number, it is called as sequence. But we cannot define the continuous time signal by using a sequence of numbers. So it is called as signal itself. So we have discussed the definition of signals, continuous time signal, discrete time signal, and now we are going to the next topic which is standard signals. First we are going to discuss about the continuous time domain standard signals, and then we will discuss discrete time domain signals. The examples of standard signals include step signal, impulse signal, ramp signal, exponential signal, etc. First, in this lecture, I am going to discuss about the step signal. The step signal can be defined as P into U of t is equal to P for t greater than 0 and 0 for t less than 0. That is, for positive time, that is the right side of the graph, it is defined as P, the value or magnitude of signal is P, and for time, that is negative time, that is left hand side of the graph, the signal is 0. The signal magnitude is 0. Then, why it is called as a step signal? We will understand it by this graph itself. That is, this graph is looking like a step or staircase. Next, we can see the unit step signal. Unit step signal is same as a step signal, but here the value at t greater than 0 is equal to 1. The magnitude of signal at t greater than 0 is 1. Hence it is called as unit step signal. And for t less than 0, the value is 0. We have specified that we are talking about continuous time signal. But we can see one discontinuity here. That is, here at t is equal to 0, we can't see anything. The same is the case of step signal, that is at t equal to 0, we cannot see any amplitude for the signal. So, for finding this mathematically, we can use Gibbs phenomenon. We can say that by using Gibbs phenomenon, we can find the signal magnitude at t equal to 0. Here we can see for the time just before t equal to 0, the magnitude is 0, and for time just after t equal to 0, the magnitude is 1. So, 0 before t equal to 0 and 1 after t equal to 0. So, using Gibbs phenomenon, we can find the value at t equal to 0 as the average of 0 and 1, that is 0 plus 1 by 2, that is equal to 1 by 2. The same is the case of step signal, that is just before t equal to 0 the value is 0 and just after t equal to 0 the value is p. So the average is 0 plus p by 2, that is equal to p by 2. So we can draw the signal as continuous signal by connecting these two. So this is step signal, and then unit step signal can be drawn as like this. So it become a continuous time signal. So even if in the definition of unit step signal and step signal it is not defined for t equal to 0, we can mathematically calculate the value as 1 by 2 in the case of unit step signal, or p by 2 in the case of step signal. Now we know the definition of unit step signal. So let's do some operations on that. The first one is shifted unit step function. Here the shifted unit step function can be defined as u of t minus a. That is, we are doing some shifting operations in unit step function. Here u of t minus a, where a is any integer value or any value. So for calculating or for deriving this, or for knowing where the discontinuity is or how we can draw the waveform, we can use the same equation of unit step function, that is u of t is equal to 1 for t greater than 0 and 0 for t less than 0. By putting t equal to t minus a, we can now see that the equation of u of t become u of t minus a equal to 1 for t minus a greater than 0 and t minus a less than 0. Here, by moving this minus a to the right hand side of inequality, we can see that u of t minus a become 1 for t greater than a and 0 for t less than a. So we can see in this unit step function, for t greater than 0 the value is 1 and for t less than 0 the value is 0. But in the case of shifted unit step function by a factor of a, for t greater than a the value is 1. So if we are putting, if a is here we are noting a. For t greater than a the value is 1 and for t less than a the value is 0. So the graph, that is shifted unit step functions graph, will look like this. Here the amplitude is same as 1. Hence it is called as shifted unit step function. The amplitude is 1 but the signal is shifted by a unit. And here we know that u of t minus a, for t minus a, the unit step function will be shifted to the right hand side by a unit. Let's see one example for this. U of t minus 4. We can use the same technique as we used earlier, that is take u of t is equal to 1 for t greater than 0, that is unit step functions equation. Put t equal to t minus 4. T minus 4 is greater than 0. 1 for t minus 4 greater than 0 and 0 for t minus 4 less than 0. And we get that the value of u of t minus 4 is 1 for t greater than 4. Earlier it is a. Here we have some value, that is 4. Let's here 4. For t greater than 4 the value is 1 and for t less than 4 the value is 0. This is the waveform for u of t minus 4. So we can conclude that u of t minus a is the right hand side shifted version of unit step function. Here a can be any value. If 1, 2, 3 or 4, any value, it will be shifted to the right hand side by that a unit. Next, we can see the example of u of t plus 5. By putting t equal to t plus 5, we will get that u of t plus 5 is equal to t plus 5, 1 for t plus 5 greater than 0 and 0 for t plus 5 less than 0. By moving this plus 5 to the right hand side of inequality, we will get for t greater than minus 5, the value is 1, and for t less than minus 5, the value is minus 5. Since we know that if multiplying with one negative sign, the inequality will be changing. That is, the less than become greater than and greater than become less than. So here the u of t minus 5 is 1 for t less than 5 and 0 for t greater than 5. Let's draw the graph that here be 5 for t less than 5, that is this part. Here it is 1 for t less than 5 and 0 for t greater than 5. By the equation we can draw the figure as like this. Now we can see the next example as u of t plus 5. Here we can use the same equation of unit step function as u of t minus 5 for a t is equal to t plus 5. Put t equal to t plus 5 in the unit step equation. For 1 for t plus 5 greater than 0 and 0 for t plus 5 less than 0. We will get that is u of t plus 5 is 1 for t greater than minus 5 and 1 for t less than minus 5. Let's draw the figure, that is here that we know that minus 5 is here. For t greater than minus 5, it is 1. That is, the graph will look like this. And for t less than minus 5, it was 0. So it is an upward moving step with discontinuity at minus 5. So we can conclude that if x of t minus t0 is the question, it will be a right hand side shifted version of x of t by t0 units. And if x of t plus t0 is the question, it will be the left hand side shifted version of x of t by t0 unit. We have here shown that is in case of u of t minus 4, it is right hand side shifted version of u of t, and in case of u of t plus 5, it is left hand side shifted version of u of t. We have seen the shifted version of u of t. Then let's check what happens if we do some multiplication. That is, if we do some multiplication in the case of t. That is, here we can see that is u of minus t. That is, we have multiplied the time t by a minus 1. So let's start with the equation of u of t, the same equation, that is u of t is equal to 1 for t greater than 0 and 0 for t less than 0. Putting t equal to minus t, we will get u of t equal to 1 for minus t greater than 0 and 0 for minus t less than 0. So by moving this minus to the right hand side of inequality, the inequality will be changing. That is, the greater than inequality will be changing to less than, and less than will be changing to greater than. So u of t is equal to 1 for t less than 0 and u of t is equal to 0 for t greater than 0. So the value, by looking at the value, we can draw the graph as u of t is equal to 1 for t less than 0. This is the t less than 0 part, and it is equal to t greater than 0 part, and it is 0. So this will be the graph for u of minus t. This is called as, that is, multiplying some value to the t is called as time scaling. So this signal can be called as time scaled unit step signal. So let's do some examples. U of minus t plus 3, that it is time scaled and shifted version of u of t. That is, minus t implies it is time scaled and plus 3 implies it is shifted. So let's start with the unit step equation, that is u of t is equal to 1 for t greater than 0 and 0 for t less than 0. Putting t equal to minus t plus 3, we get the equation as shown in the figure, that is u of t equal to 1 for minus t plus 3 greater than 0, this equation, and 0 for minus t plus 3 less than 0. Then taking the negative from minus t plus 3, it will become minus of t minus 3. So we can see that the equation will become u of minus t plus 3 is equal to 1 for t minus 3 less than 0. The less than, because we will change the inequality by using this negative, and it is 0 for t minus 3 greater than 0. So by moving this minus 3 to the right hand side of 0 or inequality, we can see that u of t is equal to 1 for t less than 3 and 0 for t greater than 3. So if here we note the value as 3, u of t is equal to 1 for t less than 3. That is, the less than 3 part is here. So here it is 1 for t less than 3, and after that it is 0 for t greater than 3. The graph will be like this. So from what we see in this examples, that we must know, that is, if a question arises, that is u of t or u of t plus 3 or u of t plus 5 or whatever it is, that is u of minus t plus 3, whatever it is, we must know where the discontinuity is. That is, where the step function is changing its value, and we must know what type of step function is this. That is, whether it is upper moving step like this or it is lower moving step like this, and where this discontinuity is happening. These are the two things we should know while we are getting some questions on unit step function. So I am discussing about some of the shortcut methods for finding these two things. Shortcut for finding discontinuity. So we have seen that if u of t plus 3, that is a shifted version of u of t minus 3, t minus 4, u of minus t plus 5, u of minus t minus 5. We are going to solve this all for finding discontinuity only. How we can find it? First take u of t plus 3, that is u of t plus 3. For finding where the discontinuity is, let's equate the term inside bracket to 0, that is t plus 3 is equal to 0. Then t equal to minus 3. So for t plus u of t plus 3, the discontinuity is at minus 3. So we can write it here. That is, here discontinuity is at t equal to minus 3. By calculating this u of t minus 4, that is t minus 4 is equal to 0, the discontinuity will be at t equal to 4. Here it is t equal to minus 3, it is t equal to minus 4 here, minus t plus 5. So putting minus t plus 5 is equal to 0, that is minus t equal to minus 5, so t equal to 5. So here the discontinuity is at 5. Then u of minus t minus 5. U of minus t minus 5. So let's check where the discontinuity will be. That is minus t minus 5 is equal to 0. Minus t is equal to 5. And t is equal to minus 5. So t is equal to minus 5. So while we are drawing this all in this same graph, we can see that for u of t plus 3, the discontinuity will be at minus 3. We don't know whether, we are not checking whether it is a upper moving step or lower moving step. The discontinuity will be as minus 3. In this u of t minus 4, the discontinuity will be at 4 here. And in the third case, the discontinuity will be at 5. And in the fourth case, the discontinuity will be at minus 5. So, next, for finding the direction of step. For finding whether the graph is or the step function is upward moving or downward moving, we can just check the coefficient of t. That is, if the coefficient of t is positive, then u of t, here it will be an upward moving step. Or if u of minus t, that is, if coefficient of t is negative, then it will be downward moving step. So we have seen how we can find the discontinuity of a function, and now we are seeing how we can find the direction of step. So let's do some examples. That is u of t plus 3. We have find the where the discontinuity will be. That is, for the first one, the discontinuity is at minus 3. For the second case, the discontinuity is at 4. For the third case, the discontinuity is at 5. And the fifth case, discontinuity is at minus 5. And while drawing the first figure, the coefficient of t is positive. So it will be an upward moving step with discontinuity as minus 3. Let here be the minus 3. And it will be upward moving step. So the graph will look like this. And in the second case, this is the graph of first one. And in the case of second one, u of t minus 4, the discontinuity is at 4, and since the coefficient of t is positive, it will be positive moving step. So the graph will look like this. This is the graph of second case. And let's consider the third case, that is u of minus t plus 5. Here the discontinuity is at 5, that is, let here be the 5, and the coefficient of t is minus or negative. So it will be a downward moving step. So before 5, the value will be 1. And after 5, the value will be 0. So let's erase all and let's do the third case. That is, in the case of this will be the 5 and it will be a downward moving step. Okay. In the fourth case, the discontinuity will be at minus 5 and it will be a downward moving step. How we can see that? That is, minus t, that is coefficient is negative. So this will be the graph of u of, if here it is minus 5, the graph will be looking like this. Clear? Till now we have seen the definition of signal, continuous time signal, discrete time signal, and unit step function, and a shifted version of unit step function, and a time scaled version of unit step function. Now we are going to discuss about the amplitude scaled unit step function. That is, till now for all shifted and scaled version of unit step function, the amplitude is 1. Now we are scaling the amplitude of signal, that is, we are changing the amplitude of unit step function from 1. That is, the equation is like u of t is, that is unit step function, u of t equal to 1 for t greater than 0 and 0 for t less than 0 for amplitude shift scaled unit step function. That is, it is represented as 4 into u of t, that is, the amplitude of unit step function is scaled. It is equal to 4 for t greater than 0 and 0 for t less than 0. That is, we can see the graph of unit step function as shown. That is, for t less than 0 it is 0 and t greater than 0 it is 1. In 4 u of t, it will look like this, where here the amplitude is 4. This is amplitude scaled version of unit step function. Now let's combine all this, that is time scaling, amplitude scaling, and shifted versions of unit step function in a simple question. Let's do this question. The question is minus 3 u of t plus 7. I will show you how we can solve the equation very easily if we have such type of equations as questions. Simply first do the time shifting and time scale part. That is, let's do first u of minus t plus 7, because this amplitude scaling, that is, we can use the minus 3, that is, multiply minus 3 with this will be your answer. So first find whether it is an upward moving step or downward moving step, and where the discontinuity is be as your challenge. The first, check for the discontinuity. For checking discontinuity, I have said that put the term inside bracket to 0, that is minus t plus 7 is equal to 0. So t equal to 7. So at t equal to 7, the discontinuity will be. And next, the type of step. Here the coefficient of t is negative, so it will be downward moving step. So we can draw the figure like this. That is, the discontinuity is at 7 and it will be a downward moving step. U of minus t plus 7 will be like this. Minus t plus 7 will be like this. And here next thing is the next thing is the coefficient of u of t. Here the coefficient of u of t is minus 3. That is, we have to multiply this u of minus t plus 7 with minus 3. Multiplying this 1, that is at till t equal to 7, it is t less than 7, it is equal to 1. Multiplying 1 with minus 3, we will get minus 3. And for 0, that is t greater than 7, it is equal to 0. For 0 into 3, it is minus 0 into minus 3, it is 0 itself. So the graph will be looking like this. All clear? So thank you, and if you have any doubts and suggestions about this video, please put comment.